So today we're going to talk about shifting quadratic functions. And if you were here for our last class, we did an activity with Desmos where we were trying to make some discoveries about what happens to an equation, or what happens to a graph when we type something different into the equation. So what we're working with specifically is the quadratic, and the quadratic that we have graphed here is y equals x squared. And before we go ahead and do parts A, B, C, and D, I'd like to put some points on this quadratic. Again, called the parent function. This is the most basic of the graphs. And the points on this graph are 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. And in general, that is a pattern on the graph. If I want to get more specific, I don't have it on this graph, but then there's 3, 9. And negative 3, 9 are two other points that are on that. We just don't have room on our picture in this particular case for that. Because the first part here says create a graph of g of x that is 2 units up from our given graph that's right there in blue. So you may want to take a colored pencil, and what we're going to do is we're going to move every point in this graph up 2. So I'll start with 0, 0. I'm going to move it up 2 spaces. And our point 1, 1, let's move it up 2 spaces. And our point 2, 4, let's move it up 2 spaces. And then on the other side, negative 1, 1, we're going to move it up 2 spaces. And negative 2, 4 up 2 spaces. And there's a picture. And if you think about what we did in the last class with our activity, the equation of that graph would look like this. Y equals x squared plus 2. And hopefully as we go throughout the day today, you'll have a little bit better understanding of where that came from. But let's look at this point 1, 1 on the graph. So that was on the blue graph here. What point corresponds to this graph on our g of x, on our green graph? Well, 1, 1 became 1, 3. And what we want to know is, do we notice anything about the x and the y coordinates on this? Well, 1, 1, 1, 3, what we, I hope, notice is that the x values stayed the same. But the y value changed. The x value stayed the same, but the y values changed when we move the graph up in this particular case. So now what you might want to do is you might want to switch colored pencils with your neighbor to get a different color, because now we're going to create a graph that's 2 units left from the given one, which in my case is blue. So with your neighbor you could change if you would like, or maybe you just want to write in pencil. But now we're going to move our blue graph left 2 units. And I'm going to start with the vertex, which is 0, 0. I'm going to move it left 2 units. So this point negative 1, 1, let's move left 2 units. Our point negative 2, 4, let's move it left 2 units. Our point 1, 1, move it left 2 units. And our point 2, 4, move it left 2 units. And notice here, that all of our pictures look remarkably similar. We're creating a transformation. In this case, what we've done is we've moved the graph somewhere, but we haven't changed its basic shape or even its orientation. So we created that graph that's 2 units left. Again, if you think back to the last class, what happens is, in terms of an equation, this would look like y equals x plus 2 squared. Well, look at the point -2, 4 on our graph. So that's our blue graph, -2, 4. And then what point corresponds to that? Well, we moved it to left. So the point that corresponds to that is -4, 4. And what do you notice in this situation? Well, what I notice in this situation is that the x values changed. But the y value stayed the same. So as you write this down here, what happens is when we move up or down, which is the x value stayed the same, our y values changed. And up and down on the graph is y-axis. When we moved left in this graph, the left is along the x-axis. That's when the x values changed. Well, let's see if we can make a generalization here. As a rule, we say that g of x equals f of x plus c when a graph moves up, when it's translated up c units. So when we add, we move up. What do you think we do when we go down? We subtract. What we just learned here a moment ago is that we moved left, and our equation was x plus 2. So when we translate to the left, this is going to be x plus c. But when we move to the right, then it's going to be f of x minus c. And now we're going to fill in our transformations rules chart. So that's another paper that you have in your hands. The first 4 values. For this function, f of x plus c. Well, f of x plus c moves our graph up c units. And something that you may want to add, maybe you don't want to add it today, but the plus c is outside of the function. And not only is it up c, but if we have f of x minus c, the function minus c, and that means that we're going to, oh, wrong color, move our graph down c units. And you will frequently hear me refer to things that happen inside the function or outside the function. And again, this is an outside of the function. We've got the function. F of x is the function, and then we're going to add or subtract something to it. Well, where's the inside? That's on the next 2. when f of x plus c, the plus c is inside the parentheses, so it's inside the function. And what happens when we add that value is we're going left c units, and finally f of x minus c. Again, it's x minus c inside that parentheses, so this is going to be right c units. And this is going to be the inside idea. Sorry about the smartboard. As I said on our original notes, it's counterintuitive. The way I oftentimes think of it is when it's inside the function, it happens the opposite way of what you think is going to happen. When it's outside the function, it happens the way you think it's going to happen. Inside, it goes the opposite way. So let's go back to our original notes and turn them over. And the thing about transformations is we can put a whole bunch in there. Again, if you were here for the last class and you did that activity that we did, on those last couple of problems, we had multiple transformations happening. Today, we're focusing specifically on our shifting. So we're focusing primarily on up, down, right, and left. So as we take a look at this first one, y equals the quantity of x plus 2 squared minus 7. Y equals the quantity of x plus 2 squared minus 7. First thing, let's go back. What's the vertex of this? And keep in mind that vertex is also known as turning point. Well, one way that we can think about it is that we change the sign and we keep the sign. So change the sign, it's going to be negative 2. Keep the sign, negative 7. But we also want to identify, well, what are those transformations? Well, we've got x plus 2 plus inside the function means that we go the opposite direction of what we think is going to happen. So we're going to go left 2. It might be nice if I spelled left correctly. Left 2. And then our minus 7. Well, it's going to go in the direction that we think it's going to go, which is down. Again, I need to spell correctly. Down 7. And now what it says below this is it says to sketch the graph. And I'm going to do the best I can here with the smartboard being wacky. But start with the vertex. Negative 2, negative 7. And I'm really sorry because it's disoriented and it shouldn't be there. But negative 2, negative 7 is our first point. And then if you think back to what we looked at the very beginning, again, all quadratics are based in the same basic pattern here. And what's going to happen now is that I'm going to go from this point, one space to the right and one up. So there's going to be a point at negative 1, negative 6. And then from the vertex, I'm going to go 2 spaces to the right and 4 up, which means that there's going to be a y-intercept at 0, negative 3. Now why are we going for? So from the vertex, we want 1 space to the right and 1 up. We went 2 spaces to the right and 4 up. So we're going to go the same way, only left. 1 space to the left and 1 up. And we're going to go 2 spaces to the left and 4 up. I'm really sorry. I'm hoping that your picture is better than mine. I cannot get it drawn on here. I'm not even going to draw it on there. I'm going to pause the video and orient again. So I was able to draw in the picture when I turned off the screen for a minute, so I do have those points in there, at least a better picture than what I originally had. Let's try this again. Y equals the parentheses, x minus 5, quantity squared, plus 2. What's the vertex, also known as the turning point? Well, once again, we change the sign, we keep the sign, so it's going to be 5, 2. And even though it's counterintuitive, x minus 5 means that we're going to go right 5 on our graph. And plus 2 is going to go the way we think it's going to go, which is going to be the up 2. And start with that point on your graph. Right 5, up 2. There's our vertex. From that point, and again, you can type this into your calculator, but if you don't have a calculator, then what we're going to do is we're going to look at the pattern. We're going to go 1 space to the right and 1 up. We're going to go 2 spaces to the right and 4 up. And we're starting at the vertex when we're counting that. So we're going to go 1 space to the left and 1 up. We're going to go 2 spaces to the left and 4 up. And if you're not sure, type it in your calculator. Look at the points in your table. Second graph gets you to the table. Letter C. Y equals the quantity of x plus 6 squared plus 4. Our vertex. Change the sign, keep the sign. Our vertex is going to be negative 6, 4. Because it's plus 6, we're going to move our graph left 6. It's plus 4, we're going to move up 4. And this is where we're going to start here on our picture. Left 6, up 4. Again, knowing the pattern on the quadratic function, the most basic of quadratic functions, can help us graph here without using a calculator. We went 1 space to the right and 1 up. We went 2 spaces to the right and 1, 2, 3, 4 up. We go 1 space to the left and 1 up. 2 spaces to the left and 4 up. And try not to make it pointed like mine is, because it's not pointed, it's curved at the bottom. It's a U-shaped curve. But one more here. Before we even do the vertex, which direction does minus 2 cause us to go? Well, hopefully you're thinking, we're going to go right 2. We go the opposite direction of what we think is going to happen. The minus 3, it's outside of the function. Means that we're going to go down 3. And ultimately that means that our vertex is 2, negative 3. So we come over here to graph. 2, negative 3. And especially for those of you who don't have a calculator. 1 space to the right and 1 up. From that vertex. 2 spaces to the right and 4 up. From the vertex, 1 space to the left and 1 up. From the vertex, 2 spaces to the left and 4 up. And there's our picture of our quadratic. So we take a look at this last problem here. We want to write the following quadratic equation in vertex form. We want to state the vertex and the transformations that occur to the parent function. And in order to do that, we need to use our complete the square method. So when we take a look at this, our first thing that we're going to do is we're going to add 1 to both sides. When we add 1 to both sides, I'm going to write 1 plus y over here on the left. There's nothing wrong with you writing y plus 1. And it equals x squared plus 10x plus something. And since we're adding something to the right side, we need to add something to the left. And to figure out what we're going to be adding, we're going to take that b value, in this case, which is 10, divided by 2, which is 5, and squared. So 5 squared is 25. Add a 25 here, add a 25 here. So we put the variables on one side, the constants on the other. We completed the square, adding that same value of b divided by 2a, or b divided by 2, quantity squared, to both sides. So now our next step is going to be to factor. We can combine that step with the fact that 25 plus 1 is 26. And over here we're going to factor. And if we take the time to write that blue step that's to the far right of the screen, then we know that it's going to be x plus 5 times x plus 5. Well, we're going to condense that. And we get 26 plus y equals x plus 5 squared. And lastly, we need to solve for y. So we're going to subtract the 26 from both sides. And we get y equals x plus 5 minus squared minus 26. Just a reminder that that's vertex form. But what we ask for in the box here isn't the vertex form, but what we ask for is the turning point. And again, the turning point is also known as the vertex. Well, our turning point, same thing that we just did. Change the sign, keep the sign. Change the sign on the 5. Keep the sign on the 26. There's our turning point. And since it's x plus 5 in the parentheses, that means that we are going to go left 5. That's one of our transformations. One of our changes to the graph. And then minus 26 means that we're going to go down 26 units.